Guys, in today's lesson, I'll be teaching us on what? On atomic structure. If this is your first time coming across my video, I want you to subscribe to my YouTube channel and also follow my Facebook page at Brewwave Online Chemistry Tutorial. So let's get started. So the ancient Greek, they were the first to use the word atom. So in the course of this teacher, our major focus will be what? On atom. Our major focus will be what? On atom. So the ancient Greek, they were the first to use this word atom. And please don't forget that the word atom means what? Indivisible, which means it means what is the smallest particle of a substance that can no longer be divided by any process, be it chemical or any process at all. So that's what the word atom means. So don't forget that the word atom means what? Indivisible. Indivisible. So don't forget that the word atom means what? Indivisible. So from here, we'll be defining what? An atom. Please take note that an atom is the smallest particle of an element that can take part in a chemical reaction. So please take note that an atom is the smallest part of an element that can take part in what? In a chemical reaction. So from here, we'll be moving straight towards to the structure of an atom. Moving straight towards the structure of an atom. And please don't forget that an atom is made up of two major parts, which include what? The nucleus, and the shell. The nucleus and what? And the shell. So these two parts make up what? The atom of an element. And of course, the nucleus can further be divided into what? Into proton and neutron. So the nucleus can further be divided into what? Proton and neutron. So proton and neutron make up what? The nucleus of an element. So you please take note of this. Now, please also take note that the nucleus happens to be what? The heaviest part of an atom. So the nucleus here happens to be what? The heaviest. The heaviest part of an atom. So please take note that the nucleus happens to be what? The heaviest part of an atom. So you please take note of this. And please, we should also take note that the nucleus is situated at the center of what? Of the atom. So the nucleus is situated at where? At the center of what? Of the atom. So you also please take note of all these key parts that I'm bringing right now. So now what about the shell? The shell spin around what? The nucleus of what? Of an atom. The shells what? Spin around what? The nucleus of an atom. And please, you're thinking that electrons are found here in the shell of what? Of an atom. So electrons, they are found where? They are found where? In the shell of what? Of an atom, spinning around what? The nucleus of an atom. So you please take note of all these areas that I'm bringing out right now. So the structure of an atom looks like this. Here we have what? Nucleus. We have the nucleus and the electron spinning around it. So this happens to be what? The nucleus. The nucleus. Now the nucleus is made up of what? Proton and what? Neutron. Proton and what? And neutron. Now this happens to be what? The spinning shell. The spinning shell, and the shell we have what? Electrons. We have what? Electrons in what? In the spinning shell. So from here, we'll not be moving straight to what? To the what? To the subatomic particles. This is what we call what? Subatomic particles. Please, if you find this class very interesting, please, I want you to subscribe to my YouTube channel and also follow my Facebook page at what? At Brewwave Tutorials. Brewwave Online Chemistry Tutorials, I beg your pardon. So let's continue with the class. Now from here, I said earlier on that we'll be moving straight to what? Towards subatomic particles. Now the subatomic particles, they are 3 in number, and they also made up what? The structure of an atom, and they include what? The proton, the electrons, and what? And the neutron. So we have what? Subatomic particles. Subatomic particles, subatomic particles. They include what? We have proton, we have electron, and then we have what? Neutron. We have proton, we have electron, and we have neutron. So the theory includes the theory of them what is what we refer to as what subatomic particles. So you should please take note that the subatomic particles include what? Proton, electron, and the neutron. Please don't forget that the proton is positively charged. The proton is what? Positively charged. Now the electron is what? Negatively charged. Please take note that charges. The proton is positively charged. Now the electron is what? Negatively charged. You please take note of it that the electron is negatively charged. Now what about the neutron? The neutron is what? Is neutral. Now when we say something is neutral, it means that it has no what? Charge. It has no positive charge. It has no negative charge. So it is what? It is neutral. So the neutron is what? Neutral. Neutral. So please, we should take note that neutron is what? Is neutral. Now please, we should take note that the proton was discovered by what? Lord Ernest Rutherford. So please take note of all this area that the proton was discovered by what? Lord Ernest Rutherford. So proton was discovered by what? Lord Ernest Rutherford. So Lord Ernest Rutherford discovered what? Proton. What about the electron? Now, the electron was discovered by what? Electron was discovered by what? J.J. Thomson. So you please take note of this that the electron was discovered by what? J.J. Thomson. So J.J. Thomson discovered what? Electron. Now what about the neutron? The neutron was discovered by what? James Chadwick. So you please take note that the neutron was discovered by what? James Chadwick. So James Chadwick discovered what? The neutron of what? Of an element. So you please take note of all these key parts that I'm bringing right now. Please, candidate and examiners, please take note of all these key parts that I'm introducing to us right now. So let's continue. So from here, we'll be moving straight to what? To atomic structure. So from here, we'll be moving straight to what? To atomic structure. From here, we'll be moving straight to what? Atomic number, I beg your pardon. Atomic number. So we'll be moving straight to what? To atomic number. Atomic number. Now, what are atomic number? Atomic number, they refer to what? The number of protons in one atom of an element. Please don't forget that atomic number, they refer to what? The number of protons in one atom of an element. So it is stated as this. It's stated that it refers to what? It refers to the number of protons in one atom of an element. So atomic number refers to what? The number of protons in one atom of an element. Please take note that the atomic number is denoted by the symbol Z. So it is denoted by the symbol Z. So please you think of this symbol. So this symbol Z is what we use to denote what? Atomic number. So you please take note of what? Of this area. So please we should also take note that for a neutral atom, we should take note of for a neutral atom, proton number is equal to what? Electron number. So please, we should take note that for a neutral atom, proton number is equal to what? Is equal to electron number. So we should please take note of all this area. Please, candidate and examinant, please take note of this what? Of this value, that proton number is what? Is equal to what? Is equal to what? Electron number. Please, we should also take note that proton number is also known as what? Atomic number. And it is atomic number that I'm explaining right now. Please note that atomic number is also known as what? It's also known as proton number. So please take note that atomic number is also known as proton number. So please, we should take note of this, that atomic number is also known as what? It's also known as proton number, which means that if atomic number has a value of 12, so it means that proton number is also what? 12. So you please take note of all these key parts and all these areas that I'm bringing out right now. So from here, we'll be moving straight to what? To the last part of this session, which is supposed to be what? The mass number. Which is supposed to be what? The mass number. We'll move it straight towards the mass number. So from here, we'll move straight towards the mass number. Now, what's mass number? Mass number is the sum of the number of protons and neutrons of an atom. Now, the sum of the number of proton and neutron is refers to what? To mass number. So it can be defined mathematically as this. Mass number equal to what? Proton number plus neutron number. Please, we should take note of this. So this is what mass number is just trying to talk about. Mass number now is the sum of the number of proton and neutron of an element. Sum simply means what? Addition. So mass number is what? Is the sum of the number of proton and neutron in one atom of an element. So we should please take note of this. We should please take note of what? Of this formula. It is very helpful. Please can you take note of this formula. Here you may be asked to calculate for mass number. So in the value, you get what? Your proton number and your neutron number. You may also be asked to look for the three values where you also use this formula. So please take note of what? Of this formula. Mass number is equal to what? Proton number plus what? Neutron number. So please, you should take note of this formula. Please, we should take note that mass number can be denoted by the symbol what? A. It can what? It can be denoted by what? The symbol. By the symbol A. Please take note that mass number can be denoted by what? By the symbol A. So you should please take note of this. That what? Mass number can be denoted by the symbol what? A. Now from here, I'll be talking about what? The nucleus symbol of what? Of an element. So from here, I'll be talking about what? The nucleus symbol of an element. I'll be talking about what? The nucleus symbol of an element. This is what we refer to as what? The nucleus symbol of an element. Now, the nucleus symbol of an element is this symbol. Please take note of this symbol. This symbol is referred to as what? The nucleus symbol of an element. Now, this symbol is majorly used in isotopy when you will be asked to calculate what? Relative atomic mass So that's where this symbol is majorly be used. Now, at the top left hand side, we have what A here, and A happens to be what mass number. While at the down left hand side, we have what Z here. While Z refers to what the atomic number. So this refers to what mass number. So our A here refers to our mass number, while Z here refers to as what our atomic number. Atomic number. While this symbol here refers to what the nuclear symbol of an element. Nuclear symbol of an element. So the A here happens to be what the mass number, Z here happens to be what the atomic number, also known as what the proton number, while this symbol here happens to be what the nuclear symbol of an element. So you please take note of all this area. So with this, we have come to the end of this class. Like I said earlier on, if this is your first time watching my video or coming across my video, I want you to subscribe to my YouTube channel and also follow my page at Brainwave Online Chemistry Tutorials. Also do well to like my videos, share, and also comment. Thank you for staying to the end.